All right, welcome to Unit 1, Entry 5. Today we're talking about the first part, density. It's split into two parts. So this should be your first day of notes this week, and we got one on Thursday as well. So let's talk about density. So density is a relationship between two specific variables. We have mass and volume. We're talking about weather patterns this week, which means that we're talking about less dense and more dense air. Okay, well, what is density? Well, it relates mass and volume. So mass is the amount of matter or stuff there is, and that's usually measured in grams. And volume is the amount of space that it takes up. Liquids are measured in liters. We would say gases are also measured in liters. And solids are usually measured in cubic centimeters. So like length times width times height. One thing to note is that 1 milliliter of water or 1 milliliter of something is the same volume as 1 cubic centimeter. Those two things are equal. So we look at these two containers down here, these pistons. You have the same amount of air, right? So the amount of gas is the same. So the amount of mass is the same. But if I compress one, the volume liter goes way down. Okay, so we're talking about high density gas. That's what we have here. Is there maybe the number of the particles are closer together. Low density, the particles are more spread apart. This would be like hot air and like cold air, and high and low densities. So density is a physical property. That means it describes not how it reacts, but how it exists. That relates mass and volume. It's the measure of the amount of matter in a specific volume or space. So if I ask these two, which of them, these two images, which had the higher density, you'd say, well, the volume is the same, length times width times height, but the amount of stuff is greater in this one, so that means it has a higher density. Remember, pause at any point if you have to. So what is the density equation? Density is mass over volume. Make sure that you write down this triangle because we'll see it coming up. So pause here and then we'll move on. So density, mass is usually measured in grams. And volume is usually measured in milliliters or cubic centimeters, which means density, which is mass over volume, will be grams over milliliters or grams over cubic centimeters. So how many grams are in 1 milliliter or cubic centimeter of space? Okay, so if I had a density of, let's say, what color are we going to go with today? Let's go with black. So if I had a density of 20 grams per milliliter, that means that for every milliliter, you have 20 grams of substance. Okay, that'd be a pretty high density. Okay. If I had 2 milliliters, I would have 40 grams. Okay, so this right here tells me per, like, and you don't have to write it, per 1 milliliter. That's what that means, or per 1 cubic centimeter. So one way to measure density or volume comes from displacement. So displacement causes a rise of water level when the solid's added. So say you have this rock that is a strange shape. You're trying to figure out the density so you can identify it. Well, when I have a graduated cylinder with a volume of 40, I place the rock in, it goes up to 60. That tells me that this irregular solid's volume is the difference. It's 20 milliliters, right? Then I could find the mass and be able to calculate the density of that object. And that's called displacement. Same thing, say you take a bath, nice Epsom salt bath, little scent there, you step in. If you filled it all the way up, the water would flow over the top of the bathtub, right? So that would be displacement. So we have two density examples here, nice short video lecture, and then you got time to work on the problems. So we have our density triangle up here. If an object has a mass of 10 grams, so this is mass, and a volume of 5 cubic centimeters, what's the density of the object? Well, whenever you do your calculations, you just cover up the variable you want to have. So I'm covering up density, and see how I have mass over volume? That tells me that my equation will be density is equal to mass over volume. And then I can just plug in my numbers. 10 divided by 5, which gives me 2. And since it's grams over cubic centimeters in this place, that's a cubic centimeter. I get grams over cubic centimeters as my units. Once you try number 2, pause the video and then see if you get it. So here I'm solving for volume. So the equation then, volume is going to be equal to covered up mass divided by density. And that's just gotten by rearranging. Oh, that's a very terrible, gigantic letter D. So density should be on the bottom here. So notice that mass is measured in grams, and this is over grams per milliliter. So just like we do with our conversions, grams is going to cancel out, so my units for volume will be milliliters. So volume is equal to mass divided by density, 10 divided by 2, which gives me my final answer of 5 milliliters. Super short video today, so we'll come back to this in a second. Your homework, you have these questions. Shouldn't be too bad. Just remember to use your density triangle. Density's down here. You got mass over volume. Okay, so make sure you use that for all these questions and do your best to answer and submit it on Thursday. So one thing to note that's different this week is that we're going to do the part 2 of gases, and I want you to submit both parts on Thursday. Okay? That gives you a chance to ask questions on your homework before then. So last thing about density is if I have the density of 2 objects, so the density of water is 1 gram per milliliter. That's the density of water, is 1 gram per milliliter. Anything that has a smaller density, so 0 point, should float. Anything with a greater density, so that means 1 point blank or bigger, is going to sink. Okay? So relative densities, the thing with the smaller number will float on top of whatever is less. Okay? So that's how we determine whether or not, and that's not the only thing that impacts whether or not an object will sink or float, but it is the primary thing that determines it. Okay? Have a great week. Love you. Complete those homework problems. Let's do number 1. I'm going to skip and do a random one. Let's do number 5. Okay, so we have our density triangle. I have density. I have mass. That's a terrible M. I have volume. It says silver has a density of 10, so that's letter D. So a block of silver has a volume of 5 cubic centimeters. What's the mass? So I cover up mass, and D and V are next to each other. So that means mass is equal to density times volume, which is going to be 10.5 times 5, which should give me 52.5. And since it's mass, it will be in grams. Notice that the density is grams for cubic centimeter. If it said kilograms, then my answer would be in kilograms. Okay, but that's what you're doing here. You're completing the other ones, and we'll go from there. Bye.